Yes, hello guys, welcome back to Tronics Energy. So we are continuing well with in our series making the 8-bit logic unit, and as we said, the 8-bit logic unit will be containing the 8 logic operations. It will be having AND, OR, NOR, NAND, XNOR, XOR, and not A, not B. So those are the logic operations that it will be doing, and all those inputs are going to be entering this multiplexer circuit, and they are going to be selected using different codes. So different codes will be representing those operations. So these are 74153. It's an IC containing two 4x1 multiplexers, and which are connected at the select only, meaning that these inputs are all different, this enable is different. So finally we are going to check on how we are going to connect these two multiplexer circuits to make one 8-bit multiplexer circuit. So that will come at the end, and we are going to check that operation later. So for today we have added another operation. It's an NOR operation. NOR operation on our circuit. Remember, we started in AND operation. We kept it, and we gave it the code. So you can see here, just put this right there. So we started with our AND operation and we gave it the code 00. We went to the OR operation, we gave it the code 01. Then we went to NAND operation, gave it the code 10, and finally we have NOR operation, and we have given it the code 11. So these are the codes that are going to be sourcing out which information that we want to receive. So these codes we feed them to this select line input, then it's going to enter the multiplexer, and the multiplexer is going to choose what you want. Either you want OR, you want NAND, you want NOR, you want AND, whichever, depending on the code that you have placed on the select line. So the NOR operation is right here. This is a NOT gate, and this is the OR gate. So the output of the OR gate, we have jumped it using this white jumper into the input of a NOT gate. That output of that NOT gate, we have entered it in D3, which is pin number 13 of our IC, pin number 13, and we have given it the code 11. So when we place 11 on our select, we are going to choose NOR operation. So for a NOR operation, for those who are new to logic gates, for a NOR operation, this is how a NOR operation looks like. When A and B are 0, it's going to give you a 1 output. That's the only time it's going to give you a 1 output. It's basically the opposite of the OR operation. Actually, it's the negated. It's just an OR operation that is being passed through an inverter. So the only time it's going to give you a 1 output is when both inputs are 0. So when both inputs are 0, it's going to give you a 1 output. When you get a 1 in either of the two inputs, it's going to give you a 0. When you have a 1 in either of the two inputs, it's going to give you a 0. So when it's 0, 0, it's only the time that's going to give you 1 output. So let's check that operation, and let's see what we mean. So our circuit is right here. We place it there, and let's power the circuit, and it's on. Yes, and we are going to start. So it's on. Both inputs are 0. On the select, we have 0, 0, meaning that we have selected AND operation. And why is the output 0? Because both inputs are 0. I think I've explained that a couple of times in the previous videos. Yes. So because both inputs are 0, it's going to give you a 0 output, because a 0, 0 on the select line chooses AND operation on the multiplexer, and the multiplexer checks the output of the AND operation. So the output of the AND operation is 0 because both inputs are 0. That's why it's going to give you a 0 output. Let's go straight in our NOR operation, and we said for us to source this, for us to select NOR in our multiplexer, we give it a code. It has its own special code. We have given it 11. So let's put 11 on our select. Yes, so our select has 11. So we have chosen the NOR operation. So we expect to see NOR operation on the output. So on our first, we have 0, 0. When both inputs are 0, we get a 1 output. Yes, that's true. And when either of the input is 1, it's going to give you a 0 output. So if either A or B is 1, it's going to give you a 0 output. Let's check if that is true. So let's put A on and the output is off. Okay, let's put B on. Let's put B on and check. Let's put B on and the output is off. Okay, let's put both of them, all of the inputs on and check, and the output is off. So that's how a NOR operation, that's how a NOR gate operates. When if either of the input is 1, it's going to give you a 0 output, and if all the inputs are 0, it's going to give you a 1 output. That's the only time it's going to give you a 1 output. Yes, so that's how it works, and we can do we can do a run through of all these operations that we have set on our multiplexer and check if it's working properly. So let's start with our AND operation, and we are going to, let me just fold this for us to see. We fold it for us to see. We are starting with our AND operation. So for our AND operation, the code is 0, 0. So we place 0, 0 on our select line, 0, 0. Yes. So 0, 0 on our select line, and let's start with 0, 0 on our inputs A and B. Yeah, like that. So when both inputs are 0, we get a 0 output. Yes. When, let's put B on, we get a 0 output. Okay, let's put A on. Let's put A on. We still get a 0 output. Let's put both of the inputs on, and we get a 1 output. So that's when both inputs are on, that's the only time the AND gate will give a 1 output. Yes. Let's go to our second D1. It's an OR gate. So the code that we have to place on our select line is 0, 1. So let's place 0, 1. Yes, 0, 1, and let's turn this off like that. So OR operation. OR operation operates in the sense that if either of the inputs is 1, it's going to give you a 1 output, and if both of the inputs is 0, it's going to give you a 0 output. So we have selected this is the code for OR. So we are doing the OR operation. We are not doing AND operation or any other operation. So let's start. When both inputs are 0, 0, we get a 0 output. That's true. When B is on, let's place B on, we get a 1 output. Yes. When A is on, let's turn off B and place A on, we get a 1 output. When both of the inputs are on, we get a 1 output. So let's place all of the inputs on, we get a 1 output. So that's OR operation. Yes. Let's move on. We are going next to NAND operation, and NAND operation, we've given it the code 1, 0. So we placed 1, 0 on our select line input. So 1, 0, 1. So 1, 0. 1, 0 on our select line. Now we are doing operation of NAND. We place A and B 0, 0 like that. Once they're 0 like that, then we start on our NAND operation. Oh, I folded it. Let me just unfold it. Let me unfold it like that. Yes. Then we are at a NAND operation. Okay, let's start. When both inputs are 0, we get a 1 output. Is that true? Both inputs are 0, we have gotten a 1 output. Yes, that's true. When B is on, we get a 1 output. Let's turn on B. LED. Okay. When B is on, we get a 1 output. That's true. When A is on, we get a 1 output. 1 output. When A is on, we get a 1 output. And when both inputs are on, we get a 0 output. That's the only time we get a 0 output, when both inputs are on. So let's put all of the inputs on and check, and we get a 0 output. So that's the only time we get a 0 output, when both inputs are on. And that's how it works. So yeah, we are moving on well. Let's finalize with the NOR gate. Yes, NOR gate. Yes, so for the NOR gate, the code is, what's the special code for NOR is 1 1. So let's place 1 1 on our select line input. So 1 1, like that. Now we are doing an NOR operation. Let's turn this off. A off, B off, like that. So let's start. When both inputs are 0, we get a 1 output. Is that true? When both inputs are 0, we get a 1 output. Yes. When B is on, we get a 0 output. Let's turn on B. We get a 0 output. Okay. When A is on, we get a 0 output. Let's turn on A. Turn off B, then turn on A. When A is on, we get a 0 output. That's true. And finally, when both inputs are on, we still get a 0 output. So when all inputs are on, we get a 0 output. So yes, and that's basically how a NOR gate operates. So I hope that you have understood how a multiplexer works and how we are moving on. I hope I'm not going too fast. I hope you're understanding what you're getting the sense of what we are making here. So we have already finished on our first multiplexer. So this D, the last D, that was our last one, and we have placed NOR. So for the NOR, you can write it as A or B, then bar, like that. So NOR operation, that was the last operation that we were to do on our first 4x1. So the other operations, so like let's say E, F, maybe G, and finally H. Okay, maybe E we are going to put XNOR, this we are going to put XOR, then G we are going to put not A, and H not B, and we will be done with our circuit. So when we're adding these other inputs, we are going to start using this final LED. You have noticed that we have not been using this final LED, so we are going to be using it when we combine these two multiplexers together. Yes, so that's basically what the 4x1 multiplexer does. And next time we are adding, we are connecting these two multiplexers to make 8x1, and we are going to continue. You can notice that we have not yet used this IC. This is an XOR IC. Yeah, we are going to use it. We are going to make XNOR using the logic gates we have. We are going to put not A, we are going to put not B, and yeah, we'll be through with our 8x1 logic unit. So thank you very much guys for watching. Please subscribe to Tronics Energy, where we do fun stuff all day all time. Hope to see you next time. Bye.